Greetings to all the viewers. I hope I find you well. I'm doing great. Welcome to another presentation on the topic organic chemistry or section organic chemistry. Right, so in this presentation, I'm going to be dealing with elimination reactions of haloalkanes and alcohols, where we have to apply a rule called the Zaitzev rule. Zaitzev's rule is used in determining the products that are formed when alcohols or haloalkanes undergo an elimination reaction. Right? Here I've written the Zaitzev's rule. I'm going to explain it before I apply it. Sit back and relax. Right, so the Zaitzev rule says a hydrogen atom is eliminated or removed from a carbon atom with the least number of hydrogen atoms. In this other funny way, we can say the rich remains rich and the poor becomes poor. I will explain it with an example. Right? Let me start with a reaction that does not require application of the Zaitzev rule, so that whenever you apply the Zaitzev rule or whenever you answer a question that involves elimination of either the haloalkanes or the alcohols, you will know when to apply the Zaitzev rule and when not to apply the Zaitzev rule. I'm going to start with bromo, 2-bromo propane. So my bromine is going to be on carbon atom number 2. Okay, so this is the haloalkane. I will react it with sodium hydroxide. Sodium hydroxide is a base, right? It has to be concentrated. Okay, if it is concentrated, okay, let me write it like this. Concentrated sodium hydroxide. If the sodium hydroxide is concentrated, then elimination reaction takes place. But if it was dilute, then a substitution reaction would take place. So in this case, it's going to be elimination reaction that would take place because our sodium hydroxide is concentrated. Right? It can also be lithium hydroxide or potassium hydroxide. That can be used for this reaction as long as it's a strong base. Bases or hydroxides of group 1 elements. Your lithium hydroxide, potassium hydroxide, sodium hydroxide. They are all strong bases. Okay? Right. So, bromine is going to be eliminated. Let me circle the atoms that are going to be eliminated. So bromine will be eliminated. It will be eliminated together with a hydrogen atom. So we are going to look at the 2 carbon atoms that are adjacent or close to the one that is holding the bromine atom. Right, we have this one and this. So they both have 3 hydrogen atoms around them. 1, 2, 3. This one also has 1, 2, 3. So they are equally rich. So you can remove from either this one or this one. It makes no difference. So there is no need for you to apply the Zaitzev rule. Okay, the product will be the same whether you eliminate a hydrogen atom from this carbon atom or you eliminate a hydrogen atom from this carbon atom. So I'm just going to eliminate this. Right, so when we eliminate this, we will remain with our 3 carbon atoms, hydrogen there, hydrogen. Now we no longer have the bromine atom, we no longer have the hydrogen atom. But our 2 hydrogen atoms there will remain there. Right, so look at these 2 carbon atoms. This carbon atom is surrounded by three bonds. This is also surrounded by three bonds. And we cannot have a carbon atom in an organic compound surrounded by three bonds. Every carbon atom in an organic compound must be surrounded by four bonds. So we have to put a double bond here. So this will be the product, an alkene, the organic product. Right, this is the organic. Right, it is the organic product. It's important to know that there is organic product that is formed and also inorganic products formed. So the inorganic products formed, HBr that has been removed, okay, it is an acid. HBr is an acid. So the HBr will react with the sodium hydroxide, NaOH. This is an acid-base reaction. The acid, hydrobromic acid, HBr, reacting with sodium hydroxide. So a reaction between an acid and a base will form salt and water. So the salt that will be formed in this reaction will be sodium combining with bromide to form sodium bromide plus the water. Okay. Right, so the second product here will be our salt, NaBr, sodium bromide, plus water. So normally when examiners ask you questions, they'll ask you to write the equation using the structural formulae. Okay, so if we are using structural formulae, like what I've done here, this bromo, 2-bromopropane, I've used structural formulae. This one, we don't show any bond. This is not a covalent compound. Here I've shown the structural formulae. Sodium bromide, it's an ionic compound. We also don't put a bond between the sodium and bromide. But water, you have to show the bonds between the atoms. So this is the reaction between 2-bromopropane with sodium hydroxide to form this organic product, propene, sodium, bromide, and water. And in this case, like I said, there is no application of the Zaitzev rule because this is more of symmetrical compound. Whatever is on this side of the carbon atom holding the bromine is the same as what is on this side of the carbon atom holding the bromine. Now let us move on to a situation whereby Zaitzev's rule has to be applied. I'm going to make use of 2-bromobutane. 2-bromobutane, let me erase this. 1, 2, 3, 4. Bromine on carbon atom number 2. Right, so that is our 2-bromobutane reacting with concentrated KOH. This time let me use KOH to be in aqueous state. Okay, so whether it's potassium hydroxide or sodium hydroxide is the same because they are both strong bases. Okay, so now looking at our compound bromobutane, the bromine is going to be eliminated. Okay, so the two carbon atoms adjacent to the carbon atom holding the bromine are this one and this one. So we have to consider which one is poor in hydrogen atoms. Like Markov is saying, the rich remains rich. So between these two carbon atoms, the first one is the rich one because it has 1, 2, 3 hydrogen atoms bonded to it. This one is poor because it has only 2 hydrogen atoms bonded to it. So this one, which is rich, it remains rich because a hydrogen atom is not going to be eliminated from it. The hydrogen atom will be eliminated from the one that is poor. Whereas they is saying a hydrogen atom is removed or eliminated from a carbon atom with the least number. So comparing this carbon and this carbon, this is 3, this is 2. So the one with the least number of hydrogen atoms is the one with 2. Okay, so my product will then be, the organic product will then be my 4 carbon atoms. Right. The bromine and hydrogen atoms have been removed. So we are going to introduce a double bond here so that all the carbon atoms are surrounded by 4 bonds. Okay? The other 2 products, the inorganic products that will be formed are the salt, which will be this time around our KOH is going to relate with HBr. So the salt that will be formed will be potassium bromide, KBr. Unlike here where it was sodium bromide. So the salt will be KBr plus the water. Okay, so this is the equation for the reaction that will take place. And we've applied the Zaitzev rule. How do you know whether you are supposed to apply the Zaitzev rule or not? Okay, the examiners normally they will say write the structure of the major product. So this is actually a major product. Once the examiner says a product is a major product, it means that product is formed according to the Zaitzev rule. This also applies even to addition reaction. For addition reaction, if the examiner says the product is a major product, it means you have to apply the Markov-Coves rule. So this is a major product which is also an organic product, and these 2 are inorganic products. Okay, so this is the application of the Zaitzev rule in the elimination of here is a hydrogen halide that has been eliminated. H and Br will be hydrogen halide. Okay, I'm going to erase this part to create some space here. Right, so this elimination reaction, name of reaction, we have eliminated hydrogen and bromine. So the reaction will be dehydrohalogenation. Dehydrohalogenation. The D means that we are eliminating. If it is just hydrohalogenation, then it will be an addition reaction. Okay? To be more specific here, the halogen that has been eliminated is bromine. So the reaction we can also call it dehydrobromination. Okay, that is our elimination reaction with the application of the Zaitzev rule. I'm now going to move on to application of Zaitzev rule to the elimination reaction of alcohols. Here for these 2 reactions, it was elimination reaction of haloalkanes. Now I will move on to, so let me just indicate this as number 1, right? Number 2, we are now removing or eliminating H2O from an alcohol. It is a reaction which also involves application of the Zaitzev rule. I'm going to make use of this compound. 1, 2, 3. Let me just put a branch here. Okay, so that is the alcohol. Okay, it's going to react with concentrated H2SO4. Elimination reaction of alcohols requires the use of concentrated strong acid, whereas elimination reaction of haloalkanes requires the use of concentrated strong base. Okay, so you must know that. Because at times they will just give you a condition for you to determine what type of a reaction is taking place. So once you see concentrated sulfuric acid being used, you must know that it's elimination of water from an alcohol. Okay, though it can also be used also in esterification. We'll look at it at some later stage. Right. So in this reaction, we are going to have the OH being removed. OH is going to be removed. Right. Now the two carbon atoms adjacent to the carbon atom that is holding the OH are these two, this one and this one. We have to now look for the one that is poor so that we make it more poor. This one is surrounded by 3 hydrogen atoms, whereas this one is surrounded only by 1 hydrogen atom. There is only 1 hydrogen atom that is bonded directly to this carbon atom. Okay, so this is the one that is poor. We are not going to look at all these hydrogen atoms. We only consider the hydrogen atoms that are bonded directly to this carbon atom. So it is only this one. So it means that it is this hydrogen atom that will be removed. Okay, because this is the carbon atom which is poor in terms of the number of hydrogen atoms bonded to it. Now let me work out the product. Right, so the product, I will just draw everything else that remains after removing whatever I have settled. Okay, so here we no longer have the OH, here we no longer have the H. So we can see that our 2 carbon atoms are now surrounded by only 3 bonds. We must include another bond to make it a double bond there. Okay, plus, in this case, water that has been removed will become the second product. Unlike here, when the HBr has been removed, it will react with the concentrated KOH to form salt in water. In this case, the water that has been removed, it will not react with any other substance. It will be our second product, our inorganic product. Okay, so this is the application of the Zaitzev rule in the elimination reaction of the alcohols. Okay, I hope you enjoyed the presentation. See you next time with many other presentations. From me, it's bye-bye.